A great day to one and all. I am Mr. Kim J.C. Ensho, and today I will be talking about some sequences that will be discussed during the grade 10 level. So this is just a sort of an introduction, and let's see what are those sequences that will be discussed. So for the first one, the first sequence of focus is what we call arithmetic sequence. When we speak about arithmetic sequence, it is a sequence in which the difference between any two consecutive terms is constant. That is, for this case, if we subtract a term by the term with the term immediately preceding it or immediately the term before it, then we get a constant difference. This constant is called common difference, which is denoted by the small letter d. That is, if you have an arithmetic sequence with terms a sub 1, a sub 2, a sub 3, a sub 4, for example, then if you subtract the second term by the first, it's equal to the difference of the third and the second term, which is also equal to the difference of the fourth and the third. And their constant difference or their value is your common difference or D. Let's have an example. If you have the sequence 1, 5, 9, 13, 17, and so on, if you have this infinite sequence, this is an example of an arithmetic sequence. Why is that so? Because if you could see the second minus first, so we go from right to left. So 5 minus 1, it's equal to 9 minus 5, 13 minus 9, 17 minus 13. All of their values is 4. And you could see that the difference of a term and the term immediately preceding it is always 4 for this case. Hence, we could say that this is an arithmetic sequence with a common difference of 4. How about the sequence for -1, -6, -11, -16, and so on? Is this arithmetic? To do this, again, we have to utilize or check if it satisfies the property mentioned earlier. So if you subtract -1 minus 4, that's -5. -6 minus -1, that will become -6 plus 1 or -5. If I have -11 minus -6, that would be -11 plus 6 or -5. And lastly, for this case, -16 minus -11, that becomes -16 plus 11 or -5. And so you could see that there is a common difference of -5. So this is indeed, the sequence is indeed arithmetic. And the common difference is -5. I hope you understood. Now, if you could notice here in the first example, let us notice the signs. If you could see here, the sign of the common difference is positive, whereas for the second case, the sign of your common difference is negative, which leads us to the next question. When is the common difference positive? And when is the common difference negative? So observe the sequence. If you see here, this one, 1, 5, 9, 13, 17, the sequence is increasing and the common difference is positive. And if you could see here, the terms are becoming smaller and smaller as you progress, and the common difference is negative. And we have to remember this. When is the common difference positive or negative? That is, let's or negative. That is, always remember that D, the common difference, is greater than 0 or it's positive if the sequence is increasing or ascending. Meaning to say, as you go from left to right, the terms become higher. And the common difference is less than 0 or negative if the sequence is decreasing or in descending order. That is, if you go from left to right, the terms are becoming smaller. Okay, I hope you understood this one. And let's have another example. Is the sequence 5, 7, 10, 15, 20, and so on arithmetic or not? And the answer here is no, it's not arithmetic. And why is it not arithmetic? Because if you could see, 7 minus 5, it's 2. 10 minus 7, it's 3. 15 minus 10 is 5. 20 minus 15 is 5. You could see that the differences of a term, the difference of a term, and the term directly preceding it or immediately preceding it, it's not constant all throughout. Hence, the sequence here is not arithmetic. Okay, I hope this is clear. Let's have this sample exercise. You are free to pause the video. Write yes if the sequence is arithmetic. If no, write no if otherwise. If you answered yes, indicate the common difference as well. So please pause the video if you wish. And if you are ready, check if you got the correct answer. All right, let's discuss letter A. If you could see, we have 18, 23, 28, 33, 38. You see that this is in fact an arithmetic sequence with a common difference of positive 5. So we have 23 minus 18, it's 5. 28 minus 23, it's also 5. 33 minus 28. 38 minus 33, it's also 5. So yes, with a common difference of 5. How about 2, 4, 8, 10, and 18? It is no. And of course, if you could see here, 4 minus 2, it's 2. 8 minus 4, that's 4. So there, you may stop because you are able to look for differences that are not equal with one another. Hence, letter B, no. How about letter C? 10, 7.5, 5, 2.5, 0, negative 2.5. This is yes. This is an arithmetic sequence with a common difference of negative 2.5 because 7.5 minus 10, 5 minus 7.5, 2.5 minus 5, 0 minus 2.5, negative 2.5 minus 0 are all negative 2.5, which is common to all of them. You have a common difference. So yes, with a common difference of negative 2.5. How about letter D? 111, 111, and 1111. This is no, of course. And how about letter E here? 3, 6, 9, 12, 15. It is yes, with a common difference of 3. I hope it's clear with us. How about letter F? 1/8, 1/4, 3/8, 1/2, 5/8. We have fractions this time. So this is, in fact, if you could see, 1/4 minus 1/8 is 1/8. 3/8 minus 1/4 is 1/8. 1/2 minus 3/8 is 1/8. 5/8 minus 1/2 is 1/8. So yes, it is still an arithmetic sequence with a common difference of 1/8. Okay, I hope it's clear. Let us proceed with the second type of sequence, and we call it geometric sequence. Let's abbreviate it with GS. And a sequence is said to be geometric in which the quotient between any two consecutive terms is constant. That is, this constant is called the common ratio. For example, if you have a geometric sequence with terms a sub 1, a sub 2, a sub 3, a sub 4, then if you divide the second by the first, the third by the second, and the fourth by the third, you will get a real value constant number, which is your common ratio, denoted by the small letter r. If in arithmetic sequence you are subtracting, you are subtracting the second by the first, third by the second, fourth by the third, in geometric sequence, to get the common ratio, you have to perform division. So for example, if I have the sequence 1, 2, 4, 8, 16, it's an example of a geometric sequence. Why? Because if you divide the second by the first, 2 divided by 1, that's 2. 4 divided by 2, it's 2. 8 divided by 4, it's 2. 16 divided by 8, it's also 2. And since all of the ratios are equal to 2, hence you have a common ratio which is 2, and hence this is a geometric sequence indeed. Take note, if you have a common ratio, then it is a geometric sequence. But if not, then it is not a geometric sequence. Let's have the second one. Is the sequence 2, -6, 18, -54, 162, and so on geometric? So let's check. If you divide the -6 by 2, that's -3. 18 by -6, that's -3. -54 by 18, that's -3 also. And 162 by -54, that's -3. So you see, you have a common ratio, which is -3. Hence, this is indeed a geometric sequence. How about this? Is the sequence 800, 400, -200, 100, and -50, and so on geometric or not? So let's test. This is actually not a geometric sequence. Why? If you could see, 400 divided by 800, or 400 over 800, it's 1/2. -200 divided by 400, that's -1/2. You could see that 1/2 and -1/2 are already different. And even without performing the other ratios or getting the other ratios, you can actually stop, because having two different values or of ratios is already an enough indication that the sequence is not geometric. I hope it's clear. There are still many topics that we will learn when we discuss formally geometric sequence. But since this is an introduction for now, so we will limit the concepts discussed here, but we will give more premium to it later on. For the meantime, let's have this exercise. I would like you to write yes if the sequence is geometric, and write no if otherwise. If you answered yes, indicate the common ratio. For example, you have 1/2, 1/4, 1/8, 1/16. This is yes, it's a geometric sequence with a common ratio of 1/2. If you have your calculators with you, you could check. 1/4 divided by 1/2 is 1/2. 1/8 divided by 1/4 is 1/2. 1/16 divided by 1/8 is also 1/2. Next one. How about negative 10, 100, negative 1,000, 10,000? This is also a geometric sequence. So yes, and the common ratio here is negative 10. 100 divided by negative 10, that's negative 10. Negative 1,000 divided by 100, it's negative 10. 10,000 divided by negative 1,000, it's also negative 10. So yes, with a common ratio of negative 10. How about 3, 6, 10, 15, 21? This is no, because 6 divided by 3 is 2. 10 divided by 6, it's 5/3. So they are not equal. So no. How about if we have a sequence composed of entirely ones as terms? Is this a geometric sequence? And the answer is yes. And the common ratio here is 1. That's why remember this. If all the terms are equal, if all the terms are non-zero, and they are all equal, then the common ratio is 1. How about 5 raised to 10, 5 raised to 9, 5 raised to 8, 5 raised to 7, 5 raised to 6, 5 raised to 5? This is also geometric. In fact, the common ratio here is 1/5. How about letter F? 1, 2, 3, 5, 8, 13, 21. This is, of course, I believe you would agree that this, no, it's not a geometric sequence. I hope you have understood this properly, and if not, you are free to verify or recheck and go back to the definition and check if it satisfies the definition of your geometric sequence. Okay, let's proceed to this one. Let's consider this. What kind of sequence is this? 4, 7, 10, 13, 16, 19, and so on. This is, it seems like you are adding 3 all throughout. So this is arithmetic. Now, I would like you to take a look at this sequence in relation to this first sequence I've given. I have here 1/4, 1/7, 1/10, 1/13, 1/16, 1/19, and so on. What have you noticed between the two sequences? Or how did I derive, or how did I get the second sequence in relation to the first? That is, if you could see, I took the terms of this arithmetic sequence and took each of its terms and took the reciprocal of each of its terms. And remember this, if you have an arithmetic sequence and you form another sequence by taking the reciprocal of its terms, then the new sequence you produce is what we call harmonic sequence, denoted by HS. So what is a harmonic sequence? It is a sequence in which each term is the reciprocal of the terms of an arithmetic sequence. That is, if the non-zero terms a sub 1, a sub 2, a sub 3, a sub 4, and so on form an arithmetic sequence, then the sequence 1 over a sub 1, 1 over a sub 2, 1 over a sub 3, 1 over a sub 4, basically the reciprocals of these terms is in fact a harmonic sequence. That's why, so that you will not get confused, the reciprocal of a harmonic sequence is an arithmetic sequence. The reciprocal of an arithmetic sequence is the harmonic sequence. In fact, harmonic and arithmetic sequences are reciprocals of each other, and provided that the terms of these arithmetic and harmonic sequences are real numbers. Let's have an example. Let's have 5, 10, 15, 20, and so on. Is this sequence arithmetic? And the answer is yes. In fact, this is an arithmetic sequence with a common difference of 5. So what is its corresponding harmonic sequence? That is, you take the reciprocal of each term, so you have 1/5. When we say reciprocal or multiplicative inverse, you simply interchange the positions of your numerator and denominator. The fact that we have whole numbers here like 5, it's understood that its denominator is 1. So the reciprocal of 5 is 1/5, and the rest are 1/10, 1/15, 1/20th, and so on. I hope you got it. Let's have another one. Is the sequence 1.5, 2, 2.5, 3 arithmetic? Let's see. 2 minus 1.5, that's 0.5. 2.5 minus 2, 0.5. 3 minus 2.5, it's also 0.5. So this is an arithmetic sequence with a common difference of 0.5. And so that you will be comfortable, I suggest you convert them to decimals, to fractions rather. So what is its harmonic? What is its corresponding harmonic sequence? To do this, I will first convert 1.5. I will just copy this, but I will convert 1.5 and 2.5 to fractions which are 3 halves and 5 halves respectively. And this one is arithmetic based on the test we did earlier. And for the corresponding harmonic sequence, we have to take its reciprocal. So for 3 halves, that's 2/3. For 2, that's 1/2. For 5 halves, that's 2/5. And for 3, that's 1/3. So this second set, the second sequence, is now a harmonic sequence. I hope you got it. How about this one? Is the sequence 10, 8, 5, 1 arithmetic? And the answer is, if you could see, 8 minus 10, it's -2. 5 minus 8, that's -3. They're not equal in the first place. So this one is not an arithmetic sequence. My follow-up is, what is its corresponding harmonic sequence? This is not arithmetic. So the thing is, does it have a corresponding harmonic sequence? And the answer is no, there is none. Remember, only arithmetic sequences have corresponding harmonic sequences. If the sequence is not arithmetic, then no corresponding harmonic sequence, and vice versa as well. Let's have another sequence or another example. Is the sequence 3/4, 3/7, 3/10, 3/13 harmonic? How do you know if it's harmonic? You can know if it's harmonic if its reciprocal is an arithmetic sequence. So this time we will be doing the reverse. Earlier, to check if it's harmonic, if it should be the reciprocal of an arithmetic sequence. This time, if it in this case, we will be doing the reverse. To determine if the given sequence is harmonic, its reciprocal should be arithmetic. If its reciprocal is not arithmetic, then the given sequence is not harmonic. So taking the reciprocals of each terms, we have 4/3, 7/3, 10/3, and 13/3. And let's see if there's a common difference. 7/3 minus 4/3 is 3/3 or 1. 10/3 minus 7/3 is 3/3 or 1. 13/3 minus 10/3 is 3/3 or 1. And you could see that this sequence is arithmetic. And since the reciprocal of the original sequence, of the terms of the original sequence, form an arithmetic sequence, then the given sequence is harmonic. I hope you understood it. Let's have these exercises. Write yes if the sequence is harmonic, and write no if otherwise. So to check this, you have to make sure that you get the reciprocal and check if the reciprocal is arithmetic. If you have 1/3, 1/4, 1/5, 1/6, this is harmonic because the reciprocal 3, 4, 5, 6 forms an arithmetic sequence. For letter B, 5, 10, 15, 20, is this harmonic? This is no, it's not harmonic. This is in fact arithmetic. Be careful. But its reciprocal is harmonic. But this one is in fact arithmetic. Be careful. Letter C, 2/5, 1/4, 2/11, 1/7, 2/17. If you take the reciprocals and subtract, you will actually see that this is in fact an arithmetic sequence. The reciprocals is arithmetic. You can verify them on your own. So yes. How about letter D? 1, 1, 1, 1, 1, 1, 1, and so on. This is also harmonic because the reciprocals will also be the same sequence 1, 1, 1, 1, 1, and so on. And this has a common difference of 0. So yes. Letter E, 1/2, 1/4, 1/8, 1/16. This is, if you take the reciprocals, this will be 2, 4, 8, 16. But 2, 4, 8, 16 is geometric, not arithmetic. Hence, letter E, no. I hope you got this correctly. And we have one more type of sequence that will be given focus this quarter, and that would be your Fibonacci sequence denoted by Fs. Let's call it Fs for now. It is a sequence in which the first and second terms are both equal to 1, and in which, starting from a sub 3, each succeeding term is the sum of the two immediate terms preceding it. That is, if I have 1, 1, then the third term will be 1 plus 1 or 2. The fourth term will be the sum of the second and the third term. 1 plus 2, 3. The fifth term will be the sum of the third and the fourth terms. 2 plus 3, 5. And this pattern continues indefinitely. Note that in some references, the Fibonacci sequence starts with 0. However, for our reference, in the reference that we are using, we will start with 1 as our first term. Okay? So let's have this exercise. So we have here so far the first 5 terms of your Fibonacci sequence. What is the sixth term? So the sixth term will be the sum of the fourth and the fifth. So 3 plus 5, that would be 8. How about the seventh term? That will be the sum of the fifth and the sixth term. So 5 plus 8 will give you 13. How about the eighth term? That will be the sum of the sixth and the seventh term. So 8 plus 13, that's 21. For the ninth term, it will be the sum of 13 and 21, which is 34. For the 10th term, it will be the sum of the 8th and the 9th terms, which are 21 and 34. 21 plus 34 is 55. For the 11th term, it will be 34 plus 55, which is 89. So these are just some of the terms of your Fibonacci sequence, and I hope that you understood how the terms are generated as well. So that concludes our lesson for today. I hope that I was able to give light to our lessons, and God bless us all, and a great day to one and all.